Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, I will cover inverse, sine, cosine, and tangent derivatives. Since we're going to cover a lot of the derivatives today, we're not going to have a daily problem today. And let's get started by reviewing our inverse function for general case. And obviously you can just derive this from inverse functions of the general case, and it is quite easy actually, but if you can memorize it, then yes, it will save you some time on the test, but it is absolutely not necessary if you cannot memorize it. The most important thing that you have to memorize is the general case of the inverse functions. And let's review that. If you have a function f of x, and that there is a function g of x that is equal to the inverse function of f of x, then if we want to find the derivative, of f of x, then it is simply equal to 1 over the derivative of g of f of x. We proved that in the last episode. And let's get started with that to derive our inverse sine, cosine, and tangent. Let's get started with our sine. So inverse sine. Obviously, inverse sine wants the derivative. Find the derivative with respect of sine of -1 of x. And obviously, this is very easy using this formula, so pause the video if you want to take a try and proceed the video when you are done. So, obviously, plugging in this formula, g prime of x. So, g of x over here, is just equal to cosine of x because it is, g of x over here is just equal to sine of x because that's the inverse of sine -1, and g prime over here is equal to cosine. So over here we just have 1 over this cosine of sine of -1 x. But you're not done yet, because this thing, although we've got the derivative of that, is still pretty annoying and include a lot of trigonometric functions. And let's see if we can simplify this a little bit more. And you might not see this instantly, but you can actually use the Pythagorean identity on this. So we can simplify that as 1 over the square root of 1 minus this sine of this thing squared. Because we know that the sine of -1 is just x. So we have this thing, the sine this thing squared. And it might be clearer if I write this as the sine of this squared, because they're just interchangeable, different notations. And this thing inside, you can see that's just x. So that's just equal to 1 over square root of 1 minus. So square root of 1 minus is x squared. So 1 minus x squared. And that is our inverse sine derivative. And now let's take a look at inverse cosine. Inverse cosine derivative. And obviously we just want to find the derivative. With respect of x of this inverse cosine function. And you can pause the video if you want to try this one. And we're actually using a very similar approach as the sine derivative, as that would be negative sine of cosine of -1 of x. Because notice that the derivative of cosine is negative, so don't forget about the negative in front. And we can use the same argument that we use for inverse sine to get that this is actually equal to So that is actually equal to the square root of 1 minus the cosine of negative 1x. So writes out like this, and this thing squared. Well, that's pretty obvious now that our final result would be 1 over square root of 1 minus x squared. And if we compare our result on both of these, we notice that it is simply just one of them is positive and one of them is negative, and the other part is identical. This part and this part is identical. And now let's take a look at inverse tangent function. So we want to find inverse tangent. Inverse tangent. And this might be a little bit trickier, and our approach is still using that. So let me write that out. We have f of x is equal to the tangent to the negative 1 of x. So our g of x is just equal to tangent of x. And f prime of x over here is just equal to 1 over g prime of f of x. And recall that if we want to differentiate tangent of x, we can just simply the tangent of x. So let's write the g prime of x, which is the derivative of tangent of x, and that is actually just equal to the secant squared of x. And over here, so we can write this as 1 over secant squared of this f of x, which is just tangent to the negative 1x. So like this. And examine this, see if you can simplify this a little bit more. Obviously you can. So 1 over secant of something, so 1 over secant, let's write that in red, 1 over secant of x, by definition, that is just equal to cosine of x. So that also applies over here, that we can just get rid of this 1 over, that will just equal to the cosine squared of tangent to the negative 1x. And after that, it will seem simpler. But we are going to do something really smart here. We are actually going to add a denominator of 1. So just dividing this thing by 1, that wouldn't influence the result whatsoever, right? And we can do that. So cosine squared of tangent negative 1x, the numerator and the denominator. 1. How can we rewrite 1 in a trigonometric form? Obviously, that is just going to be the sine squared plus cosine squared thing. So that would be sine squared of tangent of negative 1x plus cosine squared of tangent to the negative 1x. And that is our expression that we are trying to evaluate over here. Let's try to give us some space, move it over here. So we want to evaluate this thing. How do we do that? We want to get rid of the numerator, and you can see that this does look same way, but you cannot just split it up because that's not how math works. And try to simplify that. We can multiply the top and bottom by 1 over this expression. So the cosine squared times tangent to the negative 1 of x. And obviously we want to expand this as well. So it will look a lot like this. Cosine squared of tangent to the negative 1x. And that effectively gets rid of the numerator. So that's just equal to 1. And the denominator, we can do this. So this will be that. So that will be sine squared, sine of the tangent So sine of the tangent of negative 1 x over cosine of tangent of negative 1 x, that thing squared plus just this thing times this thing, so that's just 1. So what we have over here is actually 1 over this thing. This thing, sine over cosine, so that's just tangent. So that's just tangent to the negative 1x plus x. And we know that this is just x. And don't forget to square it. So there is a square over here. And that is just equal to 1 over x squared plus 1. As you can see, all three our equations of inverse trigonometric functions, they don't include a trigonometric function, none of them. And you can see that this is actually very convenient for us to solve problems. Thank you for watching this episode of Interstigation, and I will see you in the next one, where we go over the product rule expansion, where we'll see what happens when 3 functions multiply together and you want to take the derivative of that. So, goodbye, and I'll catch you later.